students. Now we are going to see the problems on maximum power transfer theorem. So the maximum power transfer theorem states when the load resistance is equal to the source resistance or circuit resistance, at that time only the maximum power is transferred to the load. That is the statement of maximum power transfer theorem. So in this problem statement they are asking to find the value of RL, and they are asking to find the what is the maximum power transferred to the load. So we need to calculate the RL value and we need to calculate the maximum power value. So first, in order to calculate the RL value, we need to find the V Thevenin for the given circuit. So when we are calculating the V Thevenin, so we are going to disconnect the RL load and we are going to indicate A point and B point like this. It is similar to that of the Thevenin's theorem. Here in this case we need to calculate the V Thevenin across these AB terminals. Okay, so if you see here we are having only one closed loop and the second one is not the closed loop. So there is no closed path. Okay, there is no connection in between A and B. Okay, so here we are having only one closed loop, that is this one. Okay, so we need to calculate the current I. So the current I, what is the formula for voltage? V is equal to IR. Therefore I is equal to V by R. So in this, the voltage is nothing but the 10 volts in this loop. And what is the resistance? The resistance is nothing but the summation of 2 plus 3. Okay, so 2 plus 3 will be the total resistance. Generally, if you see the equivalent resistance for this circuit, when if A and B are open circuit, the circuit will look like this. The circuit will look like this. A voltage source in series with two resistors. Okay, so the equivalent resistance is nothing but the summation of 2 ohms plus 3 ohms. That is the thing they have written here. Okay, so like that the I value has been calculated. So the two resistance, 2 ohms and 3 ohms, both are in series. So the current passing through these two resistance will be same. That's why they have equated I 2 ohms is equal to I 3 ohms. That means the current passing through 2 ohm resistance is equal to the current passing through 3 ohm resistance. Okay, now we have calculated the current value. Next, what we need to calculate? We need to calculate the voltage across these AB terminals. That is the V Thevenin. So V Thevenin voltage is nothing but the voltage of these resistance plus these resistance. But in this case, if AB is the open circuit, there is no voltage across these 1 ohm resistor. That's why V1 ohm voltage across 1 ohm resistance will be 0. Then the only voltage available is voltage across 3 ohm resistance. So we know the formula V is equal to IR. So here in this case the voltage value we need to find. For that we need to know the current and resistance. So already we have calculated the current across these resistors, that is nothing but 2 amps, and we know the resistance value of this. So we need to multiply 2 into 3, then we will get the V Thevenin, that is nothing but 6 volts. So we have calculated the 6 volts, that is nothing but the voltage at AB terminals will be equal to 6 volts. Next we need to calculate the R Thevenin. So R Thevenin, when we are calculating the R Thevenin, what is the condition that we need to follow? We need to replace the voltage or current sources with it equivalent resistance. So here only one voltage source is available, so we are going to replace that voltage source with the short circuit. Then the circuit will look like this. Okay, so in this circuit the 3 ohms and 2 ohms, these two are in parallel. So that's why by using the parallel resistance formula they have calculated the equivalent resistance. Now R21 is the equivalent resistance for R2 and R3. Now the circuit will change like this. If you see this circuit, in this circuit R23 and R1 are in series. So what is the equivalent resistance when the two resistors are in series? That is nothing but the summation. So R Thevenin is nothing but R1 plus R23. So what is the value of R1? R1 is nothing but 1 ohms. So here we have substituted 1 ohms. R23 value is nothing but 1.2. So we have substituted 1.2 here. So if we add 1 plus 1.2, then you will get 2.2. Okay. So in maximum power transfer theorem, RL should be equal to R Thevenin. Okay. Therefore RL is equal to R Thevenin. We have substituted here and we have drawn a Thevenin's equivalent circuit. What is the Thevenin's equivalent circuit? In Thevenin's equivalent circuit, a voltage source is connected in series with the resistance. That resistance is nothing but the R Thevenin. That voltage source is nothing but the V Thevenin. This is the thing we have drawn here. And finally we are going to connect a load resistor, that is nothing but RL. RL value is also equal to R Thevenin. That is nothing but, what is the R Thevenin? 2.2. Okay, this is the final circuit. So in this circuit what we need to calculate? We need to calculate the IL current. That is nothing but the current passing through the load resistor. So for that IL is equal to, the current I is equal to V by R. The V value is nothing but the V Thevenin and R value is nothing but the summation of these two resistance. Why? Because these two resistance are in series. So we need to take the summation here. Then we need to substitute the values of these things. So V Thevenin is nothing but 6 volts. R Thevenin value is 2.2. RL value is also 2.2. So if you simplify these things, then you will get the IL is equal to 1.63 amps. So we have calculated the L value. So what is the final thing that we need to calculate? That is the maximum power at RL. So the formula is P maximum is equal to I square R. So here the I is nothing but IL, R is nothing but RL. So we are going to substitute the IL value and RL value in this. So the IL value is nothing but 1.36 and the RL value is 2.2. So if you simplify this one, then we will get the power, that is nothing but 4.069 watts. That's it. Okay. Thank you.